Section 3.8, Implicit Differentiation. So, what is implicit differentiation? In this section, we'll focus on finding the derivative of an equation that are not functions. Consider the image below. Do these figures pass the vertical line test and the vertical line test for a function? And we see that they don't. We have a line, we have a unit circle actually, x squared plus y squared equals 1. And we see that if we wish to find the derivative, I need to find an argument for our top half and then for our bottom half in terms of x. So that I can take the derivative of x. Now, the goal of this section is to find a single expression for the derivative directly from the equation without solving for y first. Thus, we use implicit differentiation. Implicit differentiation is a type of determining rates of change and working with non-functions and other types of equations. So to begin, let's find a derivative for the equation of the unit circle x squared plus y squared equals 1. Okay, so let's just write it down. And we're going to find the derivative of each term separately. So that I have x squared plus y squared equals 1. All right, the derivative of x squared is 2x. Now what about with a y? Now this is what's new to this section. We take the derivative of y as is, as you would x. So we have 2y. But because we're not finding the derivative in terms of x, well, we are finding the derivative in terms of x, and this is a y, we're going to add a dy dx. Lastly, the derivative of 1 is 0. Okay, next piece, we solve for dy dx. By doing so, this has a plus in between. We go ahead and subtract 2x to both sides so that we have 2y dy dx equals negative 2x. We divide both sides by 2y. We have dy dx equals negative 2x divided by 2y. My 2's divide out. So that we're left with dy dx is equal to negative x divided by y. And that is our derivative. Now, for our next question, find the slope of the unit circle. Okay, well, if we wish to find the slope, then we would have to maybe find the difference or plug it into our derivative. What's cool about implicit differentiation is that I have my derivative in terms of x and in y. So I can just plug those in directly. So that we have, recall from above, we have dy dx equals negative x divided by y. So to find the slope, we just substitute those values in. So we have dy dx of, we have 1/2 comma square root of 3 over 2. That gives us negative 1/2 divided by square root of 3 over 2, which our 2's divide out, and we're left with negative 1 over square root of 3, which if we rationalize is negative square root of 3 over 3. And also for our other point, dy dx of 1/2 and negative square root of 3 over 2, we get, oh, I forgot the negative in the front. Right? Oh, I did count it in. I run the numerator. All right, so we have negative 1/2 divided by negative square root of 3 over 2. So we have the same thing, but this time it's positive, 1 over square root of 3. So we get square root of 3 over 3 as our answer. Note, Look in the denominator when deciding which differentiation you will do this to both sides of the equation. So let's list our procedure for using implicit differentiation. First, in the question, determine which differentiation you will do to both sides of the equation, then do so. Any constant will become zero. Second, if a term has a variable that has differentiate on both sides, differentiate as usual. 3, if a term does not have the variable that has differentiated but has a different variable, differentiate as if it was a correct variable. Then leave a dy dx attached to the term. 4, isolate specified rates of change. So let's do a derivative, find the derivative of the equation. Our question 2 says, find the equation of the tangent line to the curve x squared plus xy equals negative y cubed equals 7 at 3, 2. So let's begin by finding the derivative. So we can find the derivative of each term just like before at both sides of our equation so that we have 2x. Now here, they're being multiplied, right? So remember product rule. So that's x prime times your denominator, in this case y, plus x times y prime. So derivative of x is 1 times y plus x times derivative of y, which is 1 dy dx. Minus 3y squared, or my derivative of that negative y cubed, equals derivative of 7 is 0. And I forgot the dy dx. Okay, next we want to solve our dy dx's. So let's get them on the same side. So let's go ahead and subtract 2x and subtract y so that we have x dy dx minus 3y squared dy dx equals negative 2x minus y. And we do this so we can factor that out, that dy dx. So that we're left with x minus 3y squared. So that we have dy dx equals negative 2x minus y divided by x minus 3y squared. Now we're not done, right? So we also need to find the line tangent at 3, 2. So we have our equation to find our slope. Next, we find our slope by plugging in that value that we're given, 3, 2. So that we have dy dx of 3, 2, which is 2, 3 times 3 plus 2 divided by 3 times 2 squared minus 3. So that we get 8 over 9. And that's our slope. Now again, to find your equation of a line, you use your slope and your point slope formula. Alright, so your answer should be, once you work it out, y equals 8 over 9x minus 2 over 3. Example 3. Find the slope of the curve of 2x plus y raised to the 1/3 power equals y at 4 comma 4. All right, well, we have to find our derivative, right? So for the first one, we see that we have to deal with chain rule. So let's take derivative of the outside. So derivative of that 1/3. So I have 1/3 times 2 times x plus y, and then 1 minus, or 1/3 minus 1, you get -2/3. And the derivative of the inside, the derivative of x is 1, the derivative of y is dy dx, equals our derivative of y, which is 1, dy dx. Now, if you'd like to, another way of writing dy dx is by writing a prime, a y prime. So let's go ahead and do that. Let's clean this up. So we have 2/3 times x plus y to negative 2/3 power plus, times 1 plus y prime equals y prime. So let's do that for the derivative instead of writing dy dx. Okay, so we want to get y by itself, so we have to go to the trouble of multiplying all of this in so that we can undo that parentheses. By doing so, we're left with 2/3 x plus y to negative 2/3 power plus y prime times 2/3 x plus y to the negative 2/3 power equals y prime. Okay, well, let's go ahead and subtract it so we can go ahead and isolate that y prime. Now, I just wrote a squiggle to show the rest of the equation. So that we have 2/3 x plus y negative 2/3 power equals, let's factor out that y prime, so that we're left with 1 minus 2/3 x plus y raised to negative 2/3 power. All right, well, y by itself, so let's go ahead and divide. The same thing by both sides, so that we're left with y prime is equal to 2/3 x plus y to negative 2/3 power divided by 1 minus 2/3 x plus y to negative 2/3 power. Okay, now we can try to clean it up if we would like. So let's deal with that negative 2/3 power. We have two terms being divided. In my numerator, let's make that a denominator, that x plus y 2/3. And I have 2/3. In my denominator, I have 1 minus 2/3 x plus y to the negative 2/3. Okay, well, let's go ahead and divide these complex fractions. All right, I'm going to skip the work. When we divide, we'll end up with 2 divided by 3 times x plus y to the 2/3 power minus 2. And that should have been a positive. All right, what we do next is to recall what our question was telling us. Recall that y is equal to 2 times x plus y to the 1/3 power, right? From our very first initial question. Okay, well, would it be nice if we were able to get rid of this x plus y to the 2/3 power? Well, how can I make that happen with this 1/3 power? Well, I can square both sides. So if we square both sides, we'll get y squared is equal to 4 times x plus y to the 2/3 power. So that means that if we divide by 4, y squared over 4 is equal to x plus y to the 2/3 power. And isn't this the same as this? Yeah, so we can replace it with what it's equal to. So that we have 2 over 3, and instead of x plus y to 2/3 power, I'll replace it with y squared over 4 minus 2. All right, to get rid of that denominator of 4, we can multiply the top and bottom by 4. So we get 8 over 3y squared minus 2. And that was just to clean up our derivative. So much effort, right? Okay, now let's go ahead and find the slope. dy dx of the point given 4, 4 of 8 over 3, instead of y, we'll plug in a 4, squared minus 2, we'll get 1 over 5 for our slope. Okay, we're going to do a very similar technique when we're asked to do the next problem. Find the second derivative. So we're going to deal with it as before. We're going to find our derivative of each variable separately, but for a y, we'll add either a y prime or a dy dx. Depends on your preference. So if we look at this, the derivative of x is 2x, the derivative of y is 2y, but we need to add a dy dx, or a y prime. It is equal to the derivative of 0, which is derivative of 1, which is just 0. Okay, next we need to solve for y prime. So if we do so, we subtract the 2x and we're left with 2y times y prime is equal to 2x, negative 2x, divided by 2y, divided by 2y. Y prime is equal to negative 2x divided by 2y. And I need to make my y's better, right? So y prime, our first derivative, is negative x divided by y. That's my first derivative. But my question wants the second derivative. So let's take the derivative again. So y double prime is equal to, okay, well, if we look at our problem, if we wish to take derivative again, we have to deal with quotient rule. All right. Now to recall quotient rule, sorry for going back and forth, it's so we have x and y. It's our derivative of x times y minus x times the derivative of y divided by y squared, right? So that's our formula. So our derivative would be negative 1 if I attach the negative to the x times y minus the derivative of y times x. The derivative of y is 1, but we need a y prime, divided by y squared. Okay, notice this y prime. Do we know what y prime is? And we do, right? We established it here. So let's go ahead and substitute these values. So we have negative y minus x times negative x over y divided by y squared. Okay, Let's go ahead and clean this up. Let's multiply a y on top and bottom to get rid of that y in the denominator, so that I have negative y squared plus x squared equals y squared. We're almost done. But what is x squared plus y squared equal to? X squared plus y squared is actually just 1. So let's go ahead and replace that. X squared plus y squared, let's replace it with what it's equal to, which is a 1. So that we have 1 divided by, oh, we're supposed to multiply these y's. So that's a cubed, y cubed. And don't forget that negative in the front. So our y double prime, or our double derivative, is negative 1 over y cubed. And there you have it. This was section 3.8, implicit differentiation. Thanks.